Hi, my name is Christopher Gonzalez, and this is a research framework that I am working in on this summer. So the name of the research framework is basically artificial intelligence-based emotion detection in dairy cows. So the overview of the framework is there have been lately a lot of research regarding the emotional state that livestock animals could feel, such as cows, pigs, chickens, and many others. And these emotional states can make an impact on the welfare of the animal as well as the health and the overall productivity on the farm. So the objective of this framework will be to functionally detect the emotions of the livestock animal using different factors and data, and to overall finally enhance the welfare of the animal itself. So the components of this framework are based on different dataset, making it a multimodal rich dataset. So the first data component that we use is sound analysis. So with the use of microphones, we record calls from the cows that will tell us more information about their affected state that they will feel on a certain circumstance. And also we use high definition cameras to take information from the facial expression of the cows. We can use different parameters based on the facial expression, such as the ear posture, the eye wetness, and as well as the overall body language that the cow will demonstrate in certain circumstances. Also, we use sensors to effectively monitor the heart rate of the cow and different variability that is involved with it, and as well as the body temperature of the cow and a different state. So we can see here example of the data that was collected in order to make this framework. So as you can see here, this is a cow, and we have the ear posture as well as the eye awareness of the cow, and based on this we can train our machine learning model. So going more into the depth of the project itself, we got different components that are based on the machine learning model. So first of all, we gotta discuss the computational power and data that will be taken in order to make an effective model. So first of all, training machine learning model requires a large amount of computational power, and that comes directly from the hardware, as well as a large amount of data to train and make an efficient model. So based on that, we make use of machine learning methods for analyze the data that we have taken, that was mentioned here. And with this data, we use different methodologies. The first of all is supervised learning that we use to label the data for the training, and afterwards we use the deep learning models that are within the convolutional neural networks, as well as recurrent neural networks that will help us to make an effective model. Afterwards, the model training happens, and we use the different characteristics from the cow, such as ear posture, eye whiteness, and body language to train these models. So in order to make this model more optimized, we will help the farmers with some real-time data programs that will show the farmer the motion that the cow will feel on certain states, as well as a dashboard that will display this data as well. So afterwards, this dashboard will have notifications of different stress calls or the overall state of the cow and certain circumstances. So in order to validate this study and furthermore deepening the framework as well, we will have a comparison with the traditional methods such as veterinary studies to see if the models are working correctly, as well as the real assessment of veterinary to have a feedback loop to train on models. So afterwards, we got the data privacy and security. We gotta make sure that the data that we are dealing with is secure, as well as making use that the farmer and the caregiver had the proper training to use the models as well. So just wrapping up, we got the references over here and the different acknowledgements that make this framework possible. Thank you.